I will give you guys an overview of our Chiplet Design Exchange work stream. This is a new work stream that we have recently started, and it is a split from our POC work group. So there's some lessons that we learned while developing POC that got us going in this particular direction. So with this work stream, we have three main objectives. One of them is that we want to kind of at least enumerate some machine-readable formats for description of chiplets and try to come up with some kind of a standardization for it. And the second one is that we want to create a catalog of available chiplets, and we're encouraging folks to join our catalog. Some work has started on that. And the last one is that we'll hear about POC next. You will hear this concept of P-chiplet, which we call pitchlets. And it's actually a board that kind of represents the chiplet in a software development vehicle. So before you actually build a multi-chip module, if you have a silicon die, you can actually create these board-level daughter cards and put them on a PCB motherboard and build a system and develop your software on top of it. The important thing is how do we then go from there on to an actual package design? And this particular subgroup, one of the tasks is how do we take that particular netlist from the PCB and take it to a package part? And that's where this Chiplet Data Exchange and the catalog concept started coming into picture. So one very important thing that we did a bit early on, we actually conducted a survey of what do people want in terms of listing their chiplets and making information available to others. That survey result actually tells us some fundamental issues that we are facing right now, and what do we believe, how do we solve those? So I'll show you those survey results, and then we'll give you a very quick overview of how we are trying to address that particular issue. So when we started doing the proof of concept, one challenge that we came up with is, okay, how do we define these chiplets in terms of creating a system? And what type of things people would need. So people generally want to look at product briefs, data sheets, and reference designs. So that's where we started building the design, and we realized that there are multiple design tools. When data goes from one type design tool, from let's say Cadence to Mentor, there are a lot of complications in terms of converting the data, and every single company have their own solution for it. So we came up with the survey where we actually started asking folks what is important information for them, and how would they like to share this information. So the survey had about 10 questions. And these questions were around, are you comfortable sharing the functionality of your chiplet? How many voltage rails are in there? Are you comfortable sharing that? Can you share easy table? How about the XY? How about bump, physical layer? And how about thickness? How about heat map? And what are the mechanisms that you feel comfortable sharing? So there were four options, four answers. One of them was, for any of these questions, are you willing to publicly list this information about your chiplet? Option B was, are you interested in listing this information through a standard agreement, which potentially will be managed by OCP? And third one was, do a company-to-company NDA. And the last one is, yeah, I can't share this information. So the survey was completed by about 25 folks. 20 of them are familiar with Chiplets and ODSA. And there are about 11 chiplet vendors who want to be chiplet vendors. And the responses that we got, we actually put them in these buckets, like architects, executive management, business development, and engineers. So this is an overall result. So if you look on the x-axis, you will see what information people are responding for, like functions, voltage rails, pin information, XY, bump, thickness, heat map, and a little bit more on the business side towards the right. But in each one of these groups, there is the green side and the red side. Green is good. It's like people are willing to share it. And the red is that they are not willing to share. So if we take the overall response, there's overwhelming yellow, which basically says that people want to share all of this information just with company-to-company NDAs. That's how most of the folks are trained to think about it. So we started dissecting this one a little bit and see, what persona of users are actually saying what, and that is where we start picking up some interesting signals. So if we just look at the response from engineers are trained to not share any data, right? So overwhelmingly on the right side of things. So mostly red, some yellow, right? If you look at the results coming from architects, the red starts going down, and they are more inclined to, okay, we can share this information by company-to-company NDAs, right? And then comes executives and business development. That is the interesting part, where there is a interest in sharing information by using some kind of a standard agreement in place. And that is what gave us the foundation of kind of like creating this design exchange and catalog. So this signal is very important. And the more important thing is that we believe we can convert some of the folks from the red side to the green side by just going through this process of creating a catalog and making it available, right? So people are comfortable sharing this information company to company, but if OCP has a marketplace or some kind of a accepted marketplace, then through those agreements in place, there is a possibility of kickstarting this particular activity. So that was quite hopeful for us. So getting to the next point, which is at a very high level, what are we thinking in terms of developing a design flow using this Chiplet Design Exchange? So this is a complicated diagram, but it's actually, this is what we are doing in our POC. So we started with a specification for our proof of concept, and then we selected a number of chips, and then we created a PCB-based P-chiplet netlist. And the idea is that we are building a board-level design, which is the next talk that will go over that. But there is a process where you want to take these chiplets and actually come up with a package that essentially does something very similar. So all the software that you have developed on your software development vehicle can, at a later time, be used as system-level test to actually productize those designs. And in doing so, there are some smaller steps that we are trying to think about. One of them is you take the netlist from PCB and come up with a netlist for the package. And from there on, go to the EDA design tools and be able to take chiplets from multiple vendors by using a chiplet library data information and come up with a package design. That is kind of on the right-hand side. So CDX group essentially is working on defining the details of that particular area. Now, at a very high level, the description of a chiplet essentially falls in these categories. There is mechanical information, which is describing physical attributes of the chiplet. There are I/O and bump information that is more electrical in nature. So these are two essential pieces which we believe through CDX catalog, people will be willing to share through some kind of standard agreement in place. And then comes other information such as power, thermal, architectural, some specific electrical information, and security of all of this data also comes into picture. So these are the small sections of a chiplet description that we are trying to define. So you see this particular word in here, which is called ZEF. This is actually a format similar to LEF and DEF formats that are currently used in chip design for layout exchange and design exchange. So we at zGlue extended that and put it in open source, and that is one of the things that we have as one possible option. But now Cadence has joined our CDX work group, and they have XML-based die abstract format that's proprietary, but they've indicated their desire to open source it. There is another one that is open source that's available. It's called AIF. So, but the issue with those is they're very specific to the mechanical information of the chiplet. So when it goes to electrical and architectural and thermal, there's not much in those architectures that's in those file formats that you can utilize. But the good thing is we now have ASC and Cadence at least working with us in putting all the formats on the table and go through those. At a very high level, this is actually a very simple problem. If you have a chiplet, how do you define its mechanical? It's X, Y, and Z, right? But there are 30 different ways that people define them. So and truth is, when you actually do the design, there are additional items. In X dimension, you need to worry about tolerances. And same thing in Y and Z, because all of that comes into picture. So I'm just listing a bunch of field names, right? So all what we have to do is standardize these field names and say, hey, if you can refer to the X as length in a CSV format, then the others can actually just pick up your data by using that standardization, very similar to how SPICE models were developed very early on. So that is what we are trying to work on right now. So we have a kind of like a draft of the CDX work, draft proposal of CDX work as is in a 0.1 that is available to the group members only at this point. And we are trying to figure out a way how to create this common agreement in place so folks can easily share data yet have access control, so they feel comfortable getting on to the design exchange that OCP puts together. We meet once a week, sometimes once in 2 weeks, And our active participants at this point are AR Labs, Sarcina, Cadence, Eversemi, ASC, and Metronome. We are always looking for volunteers. There's quite a bit of work to be done in here. So please join us. The next few things that I would like to accomplish in here is to come up with the flow for PCB to package conversion. We want to have a Chiplet Design Exchange catalog, a preliminary version of it set up. If you have any chiplets that you would like to list on our catalog, that will be a great starting point. So, in fact, this is one of the biggest challenges that we have at this point, where people have chiplets, and it's a matter of convincing them to join our catalog. We can provide the format that they can describe their chiplet in, and it will essentially be controlled with a OCP agreement in place. We're also recently started thinking about how to put authentication mechanism and security mechanisms in place for dissemination of this design information. And I would like to hear what other things would be interesting to include in this design exchange. So that's about it. I can answer any questions.